Welcome to Pure Physics. Today we are going to see chapter number 2, Kinematics of volume number 1 of class 11 Physics Tamil Nadu board. Today is lecture number 3, and in this lecture we are going to learn about distance and displacement. So first, what is distance? Distance is the actual path length traveled by an object within a given interval of time during its motion is called as distance. It is a scalar quantity because if you want to measure the two ends of a notebook or two ends of a duster, you're gonna measure using a scale or a measuring tape. You will get the length, but it does not gives you any direction. So it is a scalar quantity, as we have learned what is scalar and what is vector quantity in our lecture number 1. And moving on to displacement. Displacement is simple. It is the difference between the final point and the initial point, or it can be said as the shortest distance between the two positions of an object. So as you can see in this diagram, if a person has to travel from the starting point and has to reach the end point, and the direction is being drawn in the red line, it also gives you the distance traveled by the object or the person who is going to travel from start to end. And it is a vector quantity because it gives you the direction of start and ending point, and also gives you the distance traveled by that person. So it is a vector quantity. Now moving on to integral calculus in physics. So in your 11th standard, in your mathematics, you will be learning about integral calculus and differential calculus in your second volume book. But in physics, you will be learning it in first volume itself. So I will just say what are the basic things in integral calculus that you are going to learn in physics. Because in mathematics, you will be learning at a later period. So whatever it is needed for physics, you will be learning in this video now. So integral calculus in physics. This is a graph and I've drawn a rectangle. Now I need to find the area. I need to find the area of this rectangle. I have taken this as a rectangle. I need to find the area of the rectangle. What do you know about the area of rectangle? Area of rectangle is equal to length into breadth. Now, how to find the length and the breadth of this rectangle? Always consider, to find the length, I need to subtract the point B and point A. So if I do B minus A, I would get the length. And the breadth is obviously from the point of origin and point C. Now how do I say that B minus A will give my length? Because consider hypothetically, if the point A is 3 and if my point B is 8, obviously point 3, that is the value of 3 is smaller than 8. 3 is smaller than more smaller than 8, right? So I cannot take 3 minus 8. If I subtract 3 minus 8, I will get in negative value, and in dimensions I should not get negative value. So if I do 8 minus 3, it will become 5. Therefore 5 will be my length, because take it in the number ways itself. 3, 4, 5, 6, 7, 8. The rectangle is between 3 and 8, right? So here there is one unit, here it is 1 unit, here it is 1 unit, here it is 1 unit, and here also it is 1 unit. So when you add all these 1 unit, you will get the whole length of the rectangle, which is equal to 5. Therefore if I subtract 8 minus 3 also, I am getting 5. Therefore 5 is the length between point A and B, hypothetically speaking, if we give the value 3 and 8. So therefore it proves that I can get the length by subtracting the values at B and A. Therefore my length will become B minus A, and my breadth will be the distance between origin and the point C. Therefore multiply it with C. This will give you my area. So So this is my area of rectangle in this case. Now, why do we use integral calculus in physics in order to find the area? Using regular shapes, that is like geometrical shapes, we can use the formula and just find out the answers. But some shapes are irregular. When the shapes are irregular, integral calculus comes into play. So now this was a rectangle. Now let me make it as a irregular shape. I'll just draw an irregular shape. Now see, this is an irregular shape. Now I need to find the area under this area of this shape. Always you need to say that this blue line is called as a curve. It's called as a curve. So we need to find the area under this curve. In your question paper or in any of the examination, if they ask you to find the area under the curve, and if they give the diagram, they will not give you this perpendicular line, this green line they will not give you. They will only give the graph and they will plot the curve and they will ask you to find the area under this graph or area under this curve. Then you need to put a perpendicular. This will be a you need to draw the perpendicular and then you need to find the area. Now I'm going to tell you how you're going to find the area under this curve. You need to divide this area under this curve into equal number of rectangular strips. So how are you going to draw the strips? I'm going to use one scale to draw the strips. So this will be my first strip. This will be my second strip. I'm just drawing randomly the number of strips. It can be n number of strips. But just to equally split it, I'm going to draw some strips. This will be my third, my fourth, fifth. This will be my sixth. And this will be my and obviously I live like this. Okay. Now these are the rectangular strips that has been equally divided the given area. Now I'm going to name this end points of the strip that are touching the x-axis as x1, x2, x3, x4, x5, x6, x7. So there are 7 strips I've drawn inside between A and B. Now I'm going to take the part in the y-axis. I'm going to plot it according to the y-axis. So I'll just add these points. I'm not going to take this x1. Okay, I'll just rename it. So this will be my curve. Okay, this will be my blue curve. Now I need to join. I'll just put a line touching each strips like this. Okay. Now I need to plot it in the y-axis. So I'll be just drawing a line so that it touches every point of the strip. So this touches the strip. So this will be my point A. This will be my point A and this will be my point B. And this will be x1, x2, x3, x4 and x5. So this will be my point C. Okay. And now this is A and B. Now I need to find the whole area under this curve. This curve is being marked as f of x. F of x is my function of this curve or the name of the curve. Now I need to find the area of each strip. If I find the area of each strip and add all the areas, then I'll be getting the approximate area under the curve. So in order to find the area, I'm going to use this formula. So this line will be named on the y axis as f of a. This will be f of x1. This will be f of x2. Like that, there will be x3, x4, x5. Right? There are 5 lines. So using this formula, I can state that the area under the curve can be obtained approximately when we add the areas of each strips. That is, I'll take area as A is equal to, now I saw that the area is equal to B minus A into uh, C, right? This is my point C. The distance between point A and x1 is delta x, and again the distance between x1 and x2 is delta x, and the distance between x2 and x3 is also delta x, and it goes on like this till point P. So these are the distance between each strip is delta x because it is evenly distributed. All these strips are evenly distributed, so the distance is delta x. Now this f of a is the breadth, so you're gonna just put b minus a is nothing but delta x. That is point x1 minus a is delta x. So in the place of c, I'm gonna just put for f of a for point a. For point a, I'm gonna substitute f of a into the distance between x1 and a, this delta x. Now we need to repeat this for other number strip values, which is nothing but x1, f of x1 into delta x plus f of x2 into delta x plus f of x3 into delta x plus f of x4 into delta x plus f of x5 into delta x plus f of b into delta x. Now when you add all these values, you will get the area under this curve. Now we know that there are 5 strips totally here, or 7 strips, including A and B. We have 7 strips, and here we know the number of strips is equal to 7. But when the number of strips tends to infinity, the summation, this whole addition, will move on to integration. I'll say how. I'll just erase this part. This can be expressed in a general form, that is A is equal to summation of n is equal to 1 from 1 up to capital N, that is number of strips. Capital N represents the number of strips that has been taken. F of xn, that is all these 1, 2 are all the suffix n into delta x. So this is my general expression of adding if we know the number of strips taken. But if number of strips taken tends to infinity, then area tends to integral. Okay. then the summation will vanish and we need to take integration. So the case that when number of strips tends to infinity will change into A is equal to integration of f of x into delta x. Since we need to apply limits for integral, the limits will be a and b. A is the starting point and b is the ending point. This a is called as the lower limit. This a is called as lower limit and b is called as upper limit. So now when n tends to infinity, the delta x tends to 0. What is the delta x? The delta x is nothing but the length between two strips. Now, if number of strips is infinite, or when we cannot say how much strips have been taken, the distance between each strips becomes smaller and smaller. As the number of strips tends to infinity, the distance between the two strips becomes 0 after becoming smaller. Therefore, delta x becomes 0. Now, we are moving on to the next part of the integral calculus, that is how to find the work and how to find the impulse under the graph. Now see, the question will be like this: find the work done under this curve. So now we need to draw the perpendicular line, which is this line and this line. This point will become point A and this point will become point B. And impulse always starts from origin at time t equal to 0. So in order to find the work done under a curve, the graph used must be always force and displacement graph, and the graph used to find the impulse should be always force and time graph. Now, in order to consider a particle is at point A and it has to be moved, or it has to be moved to point B. So work has to be done on that particle in order to move it from point A to point B. So what is the work done? If you want to find that, you need to, this is nothing but the distance traveled by the particle from point A to point B, and that distance is given as dx or delta x. Because this is displacement, so the particle has been displaced within an interval of time by applying a force. So this will be expressed as W is equal to integral of A to B, that is lower limit will be A and upper limit will be B, f of x. The curve, the function of the curve is f of x, so f of x into dx, because work done definition is work is said to be done when a force acting on a body produces a displacement of that body. So therefore, f of x into dx is equal to W. So in order to find the work done between point A and point B, we are applying integral, and lower limit will be A and upper limit will be B. And always remember, the work done graph should always be force displacement graph. F is force, S is displacement. So force and displacement graph. Now, when we come to impulse graph, always it starts from origin, that is at time t equal to 0. Now this is point A. I'll take this point A at time t equal to A second. So this is nothing but the time interval dt, and this is the function of the curve, which is f of t. So now impulse can be defined as I is equal to integration of 0 to point A f of t dt, and it's always and this impulse can be found using force time graph. Force time graph. Now moving on to average velocity. What is average velocity? Consider a particle at the point P with a position vector r1 vector. Position vector always starts from the origin. So it always starts from origin, and this is x-axis and this is y-axis. Now a particle is at a point P with a position vector r1 vector from the origin, and within an interval of time delta t, it travels from point P to point Q, and where at point Q it has a position vector r2 vector. Now what is the average velocity here? Now this is r1 vector, which is the position vector 1 and the position vector 2. Now average velocity is defined as the uh, ratio of displacement vector with corresponding interval of time. So we can define average velocity as V average is equal to delta r vector by delta t. So what is average speed? You know, speed is nothing but distance by time taken. And now when we go into the definition of average speed, now the particle has to move from point P to point Q. So the speed of that particle is nothing but that path traveled by that particle from point P to point Q by the time taken. So it can be defined as the ratio of path length traveled by the particle from P to Q with corresponding interval of time.